Okay, it's subs on the stage. So how many of you play subs on your stage when providing sound? So there is some good points of doing that. There's some reasons, but there is a big reason not to put the subs on the stage. So uh, looking at this, uh, if you have to put your subs on the slits on the stage, it can be due to floor restrictions. There's equipment. Believe me, everybody understands why a lot of times the subs need to be on the stage. And specifically, if you're at an event where there's a public and you don't have barricades or anything like that, it's good to keep the subs on the stage. But unfortunately, your subs may be sitting at far stage left and far stage right, which introduces the power alley issue, which I do have another video of. But when subs are on the stage, they can present a good balance, an image balance. But the problems with subs on the stage is that the subs will shake and vibrate. And if you have separate sound wings that are apart from the stage, that's generally a lot better, but you're still going to be running into a physics issue, which is what this video is about. So having the subs on the stage will cause things to shake, even if you have your high pass filter set on your mics, which you should anyway, but the vibrations can make their way into especially the drum kit mics. So as I said, just low frequencies end up in the mix and it can get rather muddy. But the issue with having the subs on the stage is that it causes frequency cancellations for front of house. So let's take a look at a stage, and stages are generally between 4 feet and 5 feet tall. And in our picture here, we've got just a sub sitting up there. This could be whatever. This could be on the stage right side or front house stage left, however you want to look at it. But let's say this stage is 4.5 feet tall. And what happens is that there's something called a quarter wave cancellation. And another term for this is called boundary cancellations. And I'm hoping to do a video later on about this because hopefully it'll open your eyes to a lot of issues, physics issues with where you place the speakers. So placing the subs on the stage will easily introduce what's called a quarter wave cancellation. And why it's called a quarter wave is, well, basically just what it says there. And the term the quarter wave comes from the height of the stage, which is a quarter of the distance for a sound wave. So the issue is not that the stage is 4 feet tall. A stage can be 5 feet tall or a stage can be 2 feet tall. It doesn't matter the height of the stage. It's the fact that the height of the stage is 1/4 of a distance. So basically what it's happening is on a quarter wave will come out of the speaker. Actually, it's a full wave that'll come out of the speaker. But before that wave can form, it's going to hit the ground. So it's going to come out of the speaker from the stage, hit the ground, and then bounce back up into that frequency. And that's where the cancellation issues start. So let's take a look at the height of the stage. We're going to use our 4 feet. We take 4 feet times 4. Remember, a quarter wave, it's 1/4, so it's going to be 4/4 of something. So here we got 4 feet times 4/4 times 4. That gives us our total wavelength. So in this example here, we have a wavelength of 16 feet. This is the wavelength that will be canceled when you have a sub sitting on a 4-foot high stage. So what we do is we figure in it's 1,100 feet per second for the speed of sound. We divide that by the wavelength, and that gives us the frequency that's going to be canceled. So in this example here, we're running 1,100 feet a second divided by 16 feet, and we got our 16 feet from our 4-foot high stage times 4 for 4/4, which comes up with 16. Divide 1,100 feet by 16 and we come up with 68 hertz. 68 hertz is the frequency that's going to be canceled when it comes out of this bass bin, the subwoofer, when it's sitting on a stage that's 4 feet tall. Now the 68 hertz may not seem like a lot, but that is a lot of the kick frequency that you get out of a kick drum. So just think about that. 'Cause around there, that is the kick frequency. And the 68 hertz isn't exact, and 1100 feet isn't exact either. There's a lot of variables that go in with the speed of sound, but it's safe to say that around 68 hertz, that frequency is going to be canceled. So let's take a look at a 5-foot tall stage. So let's say a stage 5 feet tall times 4 quarters. So it's 5 times 4 is 20. So we'll take 1100 feet a second divided by 20 feet. 20 feet's our wavelength, and we come up with 55 hertz. So if that stage in this picture here was 1 foot taller, the frequency canceled will now be 55 hertz. So here's what's happening. So we have a sine wave that's coming out of the speaker. And the quarter wave I mentioned is 1/4 of that wavelength. Now this wavelength hasn't completed its full wavelength and height because it's hitting the floor before it has time to develop. This is where the quarter wave comes in. What happens is it hits the floor, it bounces back up, and it creates the half wave. Well, 2 halves make a whole. So right here, this is how the cancellation occurs because there's a half wave being artificially produced. And when you have the wave coming out, blending in with the original waveform that came out of it, then we are combined waves. What happens is that the frequency gets canceled. So as you can tell here, the wave's coming out, the wave hits the ground, and then the waves cancel at 68 hertz. And once again, I'm using a 4-foot tall stage. So steps to determine a frequency cancellation: measure the height of your stage, multiply that answer by 4, then divide 1100 feet per second, and you'll have to convert that to meters for those of you who use meters. Divide the 1100 feet by the answer you get in 2, and that equals the frequency that's going to be canceled coming out of the subwoofer. So in the videos that we have, which you've probably seen a lot of our subs sitting on the ground, this is why they're on the ground. It keeps the stage clear, it keeps a lot of the bass out of the stage, and it keeps the subs on the ground. Now at 2 inches, which we have pieces of wood under the cabinets here, at 2 inches, that's absolutely nothing. In fact, what's happening here, which is part of another video we hope to do, is we're getting coupling off the ground. So having 2 of these subs sitting on the ground would be like having 4 of them sitting on the stage. So in a lot of the videos that you see, we have our subs sitting on the ground, and it's for this purpose. Now here, they're sitting underneath the stage. We could on the stage, but we're keeping the stage clear. So, to avoid the cancellations, keep the subs on the ground if possible, and we understand there are reasons why the subs need to be on the stage, but adding more EQ to correct for cancellation does not work. The cancellation is due to physics. This is not an EQ issue. So subs on the ground will add a lot more benefits than they ever will on the stage. And as always, thanks for watching, and make sure you keep your subs on the ground. We'll see you next time.